Welcome back. Today we'll be working on a new module called factoring. And we're going to develop a straightforward algorithm to factor the types of trinomials that you'll be using. Factoring is, I cannot emphasize this enough, tremendously important in college algebra because a lot of results will rely on your ability to factor. And so learning how factoring works is going to be very useful for you. So factoring. And the way I like to think about this is reverse distributive property. Now remember, whenever we did the distributive property, that basically said that if we had ax plus b times cx plus d, that came out to acx squared plus bd plus acx plus bd. And again, don't memorize that, but if you expand this out by FOIL or the box method, this is what you'll get. And so what we want to do now is go backwards. Instead of starting here and going to expanding, we want to take something that's already expanded and go backwards. So let's just start by looking at an algorithm. So step one of this algorithm, we're going to group terms with group terms with a greatest common divisor. Everything has a greatest common divisor, but if there's like one, especially if it's not one, it'll be apparent, and you'll see that in the example we'll do. And then next we'll factor out greatest common divisor out, and then we'll factor again. So let's look at an example. 2x squared plus 4x plus 5x plus 10. Now notice that this is not simplified, and this is to help you so that you know which ones to group together. So notice that as far as greatest common divisors go, these two have a greatest common divisor of 5, and these two have a greatest common divisor of 2 and x. And so we're going to go ahead and utilize that. If the greatest common divisor is 2x, that means that 2x divides both of them. So we can divide them both by 2x, right? So 2x squared divided by 2x is going to be x, right? And then let's do that more explicitly. Okay, using our properties of fractions, we can break this up. Like that. Now 2x squared divided by 2x, we can take that 2x and rewrite that, if you remember from a couple lectures ago, as 2x to the negative 1. And then we can distribute that. We get 2x squared times 2 to the negative 1, x to the negative 1, plus 4x to the negative 1, x to the negative 1. Okay. 2x squared times 2 to the negative 1 times x to the negative 1. I'm going to go ahead and simplify that. Those two cancel out. And then 2 minus 1 is 1, so we just get x to the 1, plus then we get 4x, 2 to the negative 1 is 1/2, so 1/2 times 4 is 2. And then x times x to the minus 1, you get x to the 1 minus 1, which is x to the 0, which is just 1. So we can say that if this is equal to that, then multiplying both sides by the denominator, we get that 2x squared plus 4x is 2x times x plus 2. Okay, so if we do the same thing up here for 5x plus 10, you'll see that we actually get, well, 5x divided by 5 is x, 10 divided by 5 is 2. So 5x plus 10 is going to be 5 times x plus 2. Let's go to a new page. So 2x, I'm just going to rewrite what we had before, 4x plus 5x plus, was it 10? We said that the first two terms there are equal to, let's see, 2x times x plus 4. The second two terms is equal to 5 times x plus 2. Sorry, that's not x plus 4, that should be x plus 2. Okay, notice these both have x plus 2 in common. So if we take all these out and we factor, let's go back. What we did, we grouped the terms with the GCD, we factored the GCD out, and now we need to factor again. So we're going to factor again here. X plus 2 is common in both of them, and so we can take this and divide by x plus 2. So 2x, let's do this. If we divide by x plus 2 and multiply by x plus 2, we've done nothing, right? Because we've multiplied by 1. So let's do 2x times x plus 2 all over, sorry, plus 5x plus 2 all over x plus 2 all times x plus 2. Again, we haven't done anything because we're just multiplying by 1. We're multiplying and dividing by the same thing. Now we can break this apart. These cancel out. We get 2x plus 5 times x plus 2. And look, we have a chain of equivalencies here. It's saying that this is equal to that. So we factored it. And we can double check. If we FOIL it, we get 2x squared plus 4x plus 5x plus 4. I want to do the exact same problem again, but without all these kind of intermediary steps that we did, and just kind of show you the algorithm to do it. So 2x squared plus 4x plus 5x plus 10. Okay, we have 2x squared plus 4x. Those share a common factor of 2x. So we're going to divide by 2x. First, I'll put in the grouping here in blue. We're going to group those together and group those together. These have a factor of 2x. These have a factor of 5. So the first thing we're going to write is 2x plus 5, which are those blue terms. Now the first term, the first part here, divided by 2x is x plus 2. And the second term divided by 2x is also x plus 2. Those have to match. I'm sorry, the second term divided by 5 is also x plus 2. These x plus 2s have to match. And if they do, you have your answer. Let's look at maybe a little more of a generic algorithm for whenever your terms aren't broken apart. So because this will work as long as these terms here are broken apart, but if those aren't broken apart for you, how can we find a method to break them apart ourselves? So let's do, yeah, why not just use this example again? Let's combine these and get 9x. We already know what the factors are going to be. So 2x squared plus 9x plus 10. Again, the exact same problem, right? Because we can simplify the 4x plus 5x. It's just this time they haven't told us how to break it out yet. First thing you're going to do is you're going to take 2 and multiply it by 10. And you get 20. And then you're going to write down a list of the factors of 20. So 20 has 1 and 20, but also -1 and -20, right? Because a negative times a negative is a positive. It has 2 and 10, but also -2 and -10. And it has 4 and 5, but also -4 and -5. Your next step is you're going to compute the sum. So 1 plus 20 is 21. -21. 2 and 10 is 12. -12. 4 and 5 are 9. -9. And you want to find the number in the sum that matches the number here. And you can see that is this one. Okay, so then you're going to write that. We're going to use the 4 and the 5. And then we have the exact expression we need to do what we did before here. That's how that's worked. Let's work another example from start to finish. We might need a couple of pages here for that. 2x squared plus 5x plus 3. Okay, so the first thing we're going to do, 2 times 3 is 6. Factors of 6. And there's some. We have 1 and 6. We have -1, -6. And we have 2 and 3, and -2 and -3. 1 plus 6 is 7. -1 and -6, -7. 2 and 3 are 5. -2 and -3 are -5. We're looking for a 5. We found it. So we're going to write our expression as 2x squared plus 2x plus 3x plus 3. And looking here, we have a GCD. These happen to be together. They don't have to be together, but they happen to be this time. They have a GCD of 3. These have a GCD of 2x. So we have 2x plus 3 times, well, this one, the first one divided by 2x is going to be x plus 1. And so this last one better be x plus 1. And let's check. 3x plus 3 divided by 3 is indeed x plus 1. There's our solution. Okay, that is going to be everything for factoring. You'll do a whole lot more factoring in college algebra. You're going to spend a good chunk of the course doing factoring and looking at different methods of doing that. But this method will get you there for really nice polynomials, these trinomials. Okay, next we have graphs. We have 2 more lectures.